Hi students, this chapter we are going to look at atomic structure and your periodic trends. Okay, some schools learn this as atoms and molecules. Okay, so earlier on we probably learned that matter, M-A-T-T-E-R, anything that have mass and occupy space, right? The simplest unit is your atoms. Okay, so likewise for living things, the simplest unit is your living cells. But inside your living cells, you know that there are many organelles, right? For example, you have the nucleus, you have the cytoplasm, etc. Right? So same thing for atoms, right? Even though it's the simplest unit, there are other what we call the subatomic particles inside them, subatom. Okay, subatomic particles inside the atoms. Okay, so all elements are made up of atoms, and then the atoms are all neutral. Okay, they also have subatomic particles called the proton, electron, and neutrons. I remember it as PEN. Okay, my protons have these properties. Proton symbol P has a charge of +1. Okay, P and P. So I remember it that way. So protons have a charge of +1 and then it has a mass of 1. Okay, electrons, okay, symbol E is opposite of your protons. E is the opposite of your P. So electrons has a negative charge of -1. And then it has a mass of 1/1840, which is negligible or not applicable. Very, very, very small. Okay, next one, the N, okay, come from the word neutral. Neutron come from the word neutral, so symbol is N, and since it's neutral, there's no charge, 0, and it has a mass of 1. Okay, the electrons are very light, the protons and neutrons have a mass. Okay, so protons and neutrons are heavy, they are located at the center of the nucleus. Okay, electrons are located in the shell surrounding the nucleus. So your atoms will look something like this. You have a nucleus in the middle, and then you will have some shells surrounding them. Okay, so this is the nucleus, and inside the nucleus we have the P and N because they have mass and then they are heavier, so they will be close to the center. My electrons will be arranged inside the shells. Okay, electrons will be arranged inside the shells. Okay, the atomic number or the small number in your periodic table is the number of protons in the nucleus. This is equal to the number of electrons. Okay, so if you look at your periodic table, okay, you can have element lithium. Lithium element number 3 will have this symbol Li and then 7. Okay, so this 3 is the small number or the atomic number or the proton number. So small number or the atomic number, yeah, so this 3 effectively means what? There's 3 protons. Okay, and then we have another number called the nucleon number or the mass number, which is the big number. Okay, so this number is the mass number over here, the nucleon or the mass number. Okay, the total number of protons and neutrons, right? So this one, the big number is my P plus N. Okay, why? Because it's the mass, and then your P protons have mass, the neutrons also have mass. Okay, so protons and neutrons make up the mass of the atoms, thus they affect the physical properties. Right, they affect the physical properties because they make the mass. Okay, electrons affect the chemical properties. Okay, later, second part, we will actually look at it in detail. Okay, so let's see. My small number is P equals to E. Okay, the small number in this case, my proton number, it also equals to my electrons. Okay, why? Because all the atoms are neutral. Okay, all your atoms are neutral. So my P plus must be equals to the minus. So my 3 plus must be equals to the 3 minus. Okay, so ultimate important over here, the small number, it tells me the P and E. The big number tells me the P plus N. Okay, big number is the big number over here, right, is the mass number. Okay, is the nucleon number or the mass number. So this big number tells me the P plus N. Okay, so if I take the big number minus the small number, you will know how many neutrons are inside. Okay, so back to this lithium example, when you see the symbol like this, okay, Li 3 and 7, you know there's 3 proton, 3 electron, because small number P equals to E. Okay, and then there is neutron, there is 7 minus 3 equals to 4 neutron. Okay, from the symbols in your periodic table, you will be able to tell what are the subatomic particles inside them. Okay, this picture over here, let me zoom in a little bit and then look at it in detail. Okay, so this picture over here shows you, gives you an illustration or an example. Okay, if I have an electric beam that can shoot the proton, neutron and electron out, okay, and then this electric beam will shoot the proton, neutron, electron out, and then this electric beam, right, there are 2 plates over here. This plate is a negative plate and then this plate is a positive plate. Okay, so when you shoot the proton, neutron, electron out, right, because this plate is the positive plate, your electrons will get attracted to it. Okay, my protons will get attracted to here, P plus. Okay, why is your electrons attracted to the positive plate? Because electrons are negatively charged. Okay, and then if you look at the band, right, your electrons get deflected a lot more. Why? Because electrons is very light. 1/1840, there is hardly any mass. So your electrons very light, it can bend more. The proton's relative mass is 1, so it bends less. Okay. Over here, this part that doesn't get deflected, doesn't bend at all, this one is your neutron. Neutron does not get attracted to the plates because they are neutral. Okay, so it doesn't deflect, it doesn't bend.